In this video, we're going to talk about how to graph y equals sine x and y equals cosine x. We're going to deal exclusively in radians. That's what the world will live in next year in AP Calc. We're going to kind of use, in the first case, our unit circle and our understanding of the values of sine and cosine in quadrant 1. And then we'll kind of shorten it up a bit after that. And then we'll talk about some of the features like we had before, period, amplitude, midline, whether it's an odd or an even function. And then we'll add in all the other stuff that we have before, the reflections, translations, stretches, and shrinks. Okay, starting with sine x, we know that sine starts small, so at 0, sine of 0 is 0. And at pi over 6, we get square root of, we get 1/2. So at pi over 6, which is going to roughly be, let's see, there's half. So a fourth is going to be right in about there. We're going to be up to 1/2. At pi over 4, which is roughly 3/4, then we're going to be up to square root of 2 over 2, which is about 1.4 over 2, which is a little more than 1/2. So we're going to be up to about here. At pi over 3, we are going to... Oh, hold on there. I'm not doing that right. So hold on. I need to know. I'm going to mark on here the over 2's. So let's mark on there a pi over 2. And that's going to be a 3 pi over 2 there. Okay, so there's pi over 2, and pi over 4 will be about halfway through. So pi over 6 is going to be maybe about right in there. So there was where we're going to be at 1/2. At pi over 4, we're like 1.4 over 2. At pi over 3, we're going to be 1.7 over 2. And at pi over 2, sine is going to be 1. So we're going to work our way up to kind of a curve like this that's going to reach a high point of 1 at x equals pi over 2. Now, by the time we get to pi, we're going to be back down to sine of pi is 0, and we're going to descend in that same order as we work our way down. So this part of the graph will be symmetric to this part of the graph. They're like mirror images of each other. And then we're going to move into the negatives. So once we get below past pi, now the sine values, the y values, are going to become negative. They're going to reach a very low here at -1, and that's going to occur at pi over 2. So we're going to get this kind of curve in this way. And then as we work our way back towards 2 pi, we're going to go back to where we started. So we're going to get this kind of a curve that this kind of, I call a loop above and a loop below. Now we're back to where we started, because 2 pi is just like being at 0, so it's going to repeat itself over and over again. So we're going to get another loop by the time we get to 3 pi, and another loop by the time we get to 4 pi. Similarly, we can do the same thing going in the negative direction, and so we're going to see this thing goes on and on forever. So it is what we call a periodic function. It repeats itself over and over again. We talked about this a little bit before. We can say the period, that fundamental period, the shortest horizontal distance that we travel in doing one complete cycle, it's called, is going to be 2 pi. So we're going to say our natural period for sine is 2 pi. Its amplitude, remember we said, is the largest value, the max, minus the min, and then divide that by 2. So the largest we ever get is a positive 1. The smallest we ever get is a negative 1. And so the amplitude of the sine curve is going to be 1. We have what we've called the midline before. So the midline, that graph that cuts that periodic function right down the middle, is going to be y equals 0. That's going to be the middle of our graph there. We can see that things we've talked about before, like domain, the domain of the sine function is all real numbers. It goes on and on and on forever. The range of our function, it just goes from -1 to +1. And you can see if you look at this, we've talked about odd and even functions. This, believe it or not, has symmetry in the origin. If you hold your pencil on the origin and turn that 180 degrees, it lands right back on itself again. Or sometimes you can think of it as a double reflection. If you reflect in the x and then in turn reflect that in the y, it's going to land right back on top of itself again. So the sine function is an odd function as well. Okay, that's a lot to throw at you there. Sometimes it's called a sine wave because you can kind of see it sort of looks like an ocean wave that goes on and on and on. You might also recognize that it, if you are a musician and you talk about pitches and sound traveling in waves, those can be modeled with sine and cosine curves as well. Let's turn our attention to the cosine curve. And in a similar fashion, at 0, cosine of 0 is 1. And I'm going to put in there is going to be pi over 2. So by the time we get to pi over 2, well, let's see, at pi over 6, so that's pi over 2, pi over 6 is going to be right in there. Then we get square root of 3 over 2, which is going to be like 1.7 over 2. And then at pi over 4, we're going to be at square root of 2 over 2, which is a little bit more than a half. When we get to pi over 3, we're going to be at a half. And then it's going to get to, by the time we get to pi over 2, it's going to be 0. And I'm not drawing that very curved, but it needs, I'm going to try to fix it. That should look more like a curve. When we get to pi, cosine of pi is -1, so it's going to come down as a curve there. At 3 pi over 2, we're back to 0. And at 2 pi, we're going to be back to 1 again. And so it's going to repeat itself over and over again. So we are going to, let's see, at 3 pi, we're at -1. And so it's going to do something like this. And likewise, in the opposite direction, it continues on and on and on. And so you can see that sine and cosine are actually congruent curves. They're exactly the same size and shape, but they're just translations of each other. If you moved our cosine curve over a pi over 2, it would be a sine curve. It would be identical. So its period is also going to be 2 pi. Its amplitude is also going to be 1. And its midline is also going to be y equals 0. Its domain is also going to be all real numbers. Its range is also from -1 to 1. Now if you notice, if you reflect that in the y-axis, the sine curve is an even function. It has symmetry in the y-axis. Okay? Now, let's see what we can do with these as we start to do things like stretching, shrinking, reflecting, and so on. So here is our 4 times the sine curve. So we know that the biggest a sine can ever be is 1. That's going to get multiplied or stretched vertically by 4. So that means we're going to get a high value of 4. And since the smallest value is -1 for a sine curve, then 4 times that will be a -4. Now we're going to plot the important points. I'm going to scroll up for a moment. The important points on both the sine and cosine curve that we're going to look at for graphing purposes is what happens every fourth of a period. So every fourth of a period, so our period's 2 pi, so we're going to say where does it start, and I'm going to use the words a sine curve starts in the middle. I'm going to say a cosine curve starts big. And then I'm going to say a sine curve is going to do a loop above. So we're going to go to a high point after we go over a fourth of a period, back to the midline after another fourth of a period, to a low point after another fourth of a period, and back to the midline after a fourth of a period. So these points that I plot are going to be every fourth of a period. I'm going to say a cosine curve starts big, and then we're going to do that half loop above. So then we'll go to the midline, to a low point, to the midline, to a high point. And again, every fourth of a period is where we get those important points, and then we'll connect them with what we know the curve to look like. Okay, so we are going to say that, I can move this. Okay, so let me get back to my blue pen. So sine starts in the middle, so at 0 it's going to be 0. At pi over 2, our fourth of a period is going to be at a high point, which the sine of pi over 2 is 1, times 4 is going to take us all the way up to 4. At pi, the sine of pi is back to 0, times 4 is going to be 0 again. At 3 pi over 2, the sine is negative 1, times the 4 will take us to a low value of negative 4, and at 2 pi, sine of 2 pi is going to be 0 again. And so we're going to see very clearly this vertical stretch. So our period remains 2 pi, but our amplitude now has become 4. Okay, that's what's going to change. Okay, in the cosine curve, we're going to start at 0, and at 0 cosine is 1, and multiplying by a negative 3 is going to move this down to negative 3. So we're going to start at 0, negative 3. At pi over 2, the cosine is 0, and so we're going to be back to 0. At pi, cosine of pi is negative 1, times the negative 3 will take us up to a high value of positive 3. At 3 pi over 2, cosine is again 0, and so that's going to be 0, and 2 pi is going to be back to a negative 3. So I'm trying to draw this so it looks curved, but it's pretty stretched out here. So we're going to get something that looks like that. That's one cycle or one period of a negative 3 cosine x. Now its amplitude. Amplitude, if we think of this as being y equals a sine or cosine x, the amplitude is going to be the absolute value of the a. So the amplitude is always going to be a positive number. It's going to be a 3. And our period remains 2 pi. We haven't done any stretching or shrinking horizontally yet. Okay, let's move this up a bit. So here is now, we're going to add in this plus 3 is going to be a translation vertically. So our midline, which was at y equals 0, is going to get moved to y equals 3. So this is going to be the center, or the middle, of our cosine graph. It's going to wind its way above and below. Now at 0, cosine is the biggest. It starts big. So cosine of 0 is 1, times 2 is 2, plus 3 is going to put us up at 5. So we're going to start at 0, 5. At pi over 2, cosine is 0, times 2 is still 0, but plus 3 is going to take us to the midline, 3. At pi, cosine is negative 1, times 2 is negative 2, plus 3 is a positive 1. That's going to be our low point. At 3 pi over 2, cosine is 0 again, which will take us back to the midline. And at 2 pi, we're being back to 1, which will take us up to 5. And so our graph is going to be, trying to make this look like a cosine curve. There we have it. So period is still going to be 2 pi. Amplitude still going to, well, it's going to be in this case 2. And we've just done a translation. So let's look at the horizontal stretch and shrink. Like I said, I think this is where people, I think, get a better appreciation of how these compare and contrast. Because now I think the idea of talking about speeding it up or slowing it down makes better sense. I'm going to just first draw like the parent function for our sine curve, just to have there as a comparison. So I'm going to mark these with those every fourth of a period, and here's going to be our 1 and our negative 1. So sine curve starts in the middle, then does the loop above, and so this is our parent function. And we can see the period is going to be 2 pi. Now this 2 is going to speed things up. It's going to make the period be half as long. So it's going to be 2 pi divided by 2 is going to be pi. those important points that we graph every fourth of a period, I call, this is a Mr. Street made up name for these, I call them critical points, are going to be every fourth of a period, which means every pi over 4. I'm taking the period pi divided by 4. So I'm going to put tick marks at every pi over 4. There's pi over 4, 2/4, there's 3 pi over 4, and there's 4/4. So now our cosine curve, or our sine curve rather, is going to start in the middle, but it's going to have its peak, its high point at pi over 4. It's going to be back to 0 at pi over 2, to a low point at 3 pi over 4, and back to the midline at pi. And so you can see this idea of it's sped up. And if we were to continue this again, then what we would see is we are going to get 2 full cycles in the same horizontal distance, which I like to kind of think of as a time measurement. We're going to get 2 complete cycles in the same time it took to complete 1 cycle with the parent function. So I think that makes better sense with the time analogy here. Now the 1/2 here is going to stretch things out. So our period is going to be 2 pi divided by 1/2, which is going to make that be 4 pi. So much wider, much slower. What I call critical points are going to be every fourth of a period. So that's going to tell me where to put the tick marks. So I'm going to mark pi, 2 pi, 3 pi, and 4 pi. And there's going to be 1 and -1. So a cosine starts big, so we're going to be here. Then we're going to go to the midline, to the low, back to the midline, back to the high. And so this has been stretched out, and we can see our period is twice as long. It's going to take a horizontal distance of 4 pi, or time, if you will. It'll take 4 pi seconds, or whatever you want to refer to that as, to complete 1 full cycle. Amplitude is still going to be 1. That hasn't changed, and our midline is still the same. Let's look at one more of these, and then we'll throw in a reflection, and then we'll start doing really complicated stuff. So our sine curve, remember we said is an odd function. So an odd function, I'm going to draw just over here, kind of off to the side, our parent function. So our sine curve, remember, does this. And so if we reflect it in the y, then it's going to look something like this, which is, in the case of an odd function, the same as reflecting it in the x. So this negative here is the same as a negative on the outside. It's going to end up being a reflection in the y-axis, which is going to look the same as a reflection in the x-axis. Okay, period. Let's see what that does. It's going to be the normal period, 2 pi. Now we divide it by the absolute value of b, if we're thinking of this as sine of bx. So the sign doesn't matter in terms of the period, the positive or negative sign. So this is going to be 2 pi divided by pi over 4. That's going to be 2 pi times 4 over pi. We get to cancel the pi's and get 8. So our period is 8. Our critical points are going to be every fourth of a period. So I'm going to put tick marks every 2. So I'm going to go 2, 4, 6, 8. And our amplitude remains 1. So we're going to have a high value of 1 and a low value of -1. I'm going to treat, because of the odd nature of sine, I'm going to treat the reflection in the y as reflection in the x. So instead of doing the usual loop above and then loop below, I'm going to do the loop below first. So we're going to go from 0 to a low point, to the midline, to a high point, to the midline. And so we're going to get something that looks like that. All right. Let's see if we can put it all together here. and graph one of these. Now we see the green one here is in factored form, which is going to save us some work. The blue one is not in factored form, so we're going to have to do that first. Let's see if we can state what is the period and what is the amplitude. So the period is going to be 2 pi divided by, here's the number that's multiplying that x, that's the 2. So our period is pi, which means we're going to put our tick marks every pi over 4, but I'm not going to do that just yet. This amplitude is going to be the absolute value of the number multiplying it there. So the amplitude is going to be 2. Now the pi over 6 here is going to be a translation left pi over 6. So we're going to think of this cosine curve as starting at a negative pi over 6. Let's see what we've got going on here. So I'm going to go to a negative pi over 6. I'm going to call that negative pi over 6. And our tick marks are going to be every pi over 4. So I'm going to, from negative pi over 6, the next point that I want to graph is going to be pi over 4 to the right of that. So I'm going to add pi over 4 to the negative pi over 6 to get that next tick mark. So going to common denominators of 12ths, a negative 2 plus 3 twelfths is going to make that be a positive pi over 12. Then I'm going to add another pi over 4 to that to get the next tick mark. So I'm going to think of that pi over 4 as being 3 twelfths. So you can call that 4 twelfths if you like. I can hardly resist reducing it. The next one, to that 4 twelfths, we're going to add another pi over 4, which is 3 twelfths. That's going to be 7 pi over 12. Now I'm going to do this 4 times in addition to where I started. So there's 1, 2, 3, 4. This is my last one. I'm adding another 3 twelfths to the 7 twelfths. That's 10 twelfths, or 5 pi over 6. Okay, now this minus 3 is going to translate this whole thing down 3. So our midline, which was at 0, is going to go down to negative 3. I'm going to just make a little dotted line so I don't lose where that's going to be the middle of our graph. Since our amplitude is 2, you don't have to do this, but I like to put a little boundary line that's 2 above and 2 below where our midline is. So that's going to be at negative 1 and at negative 5. So our graph is going to go bouncing in between those tallest and smallest horizontal lines there. Okay, I think we're making progress. So we're going to start at a negative pi over 6. This is a cosine curve, which starts big. So at negative pi over 6, I'm going to put a point at negative pi over 6 comma negative 1. I'm going to go over one critical point, and I'm going to plot a point in the midline. I'm going to go over another critical point and plot a point at the low. Another critical point takes us back to the midline, and then another critical point back to a high point where we started. And then we'll try to connect those with a nice smooth curve. And there is our cosine. All right, I'm going to slide this over a little bit, and let's see if we can do the same thing with our sine curve. So I'm going to put a little XY axis there. Now here, the first thing we want to do is factor out the pi over 4 that's in there. And so that's going to give us an x minus 1. So now we can see the effect of the horizontal. It's going to be a little bit of a stretch since pi is about 3. 3/4 is a little bit less than 1. So it's going to be a very small stretch, and that's going to be different from our horizontal translation. So our period is going to be 2 pi divided by the pi over 4. That's 2 pi times 4 over pi. That's going to be 8. Our critical points are going to be every fourth of a period, so we're going to put our tick marks every 2. Now remember, our starting tick mark is going to be 1 to the right. So I'm going to go, there's 1, and then we're going to go, the next one is going to be at 3, 5, 7, 9. How many do I have? 1, 2, 3, 4, 5. That's good for 1 full period. Our midline, this thing is going to be translated up 1. So I'm going to call that 1. And there's going to be the middle of our graph. And our amplitude is going to be 3. So from the midline, I'm going to go up 3. That's going to put us at 4. And I'm also going to go down 3 and kind of put the basement. 1, 2, 3. That's going to be at -2. So these are the boundaries of our graph. We're going to go between -2 and +4. Let's see. So we have a negative sine curve. Sine starts in the middle, and our middle is going to be at 1, 1. So at 1, 1, I'm going to put the middle of our sine curve. Now, normally for a sine curve, I'd go up, but because this is a negative sign, I'm going to go down. So at 3, that's going to be our low point. 5 goes back to the midline, 7 to a high point, and 9 back to the midline. And this is one full cycle of our sine curve. All right, very good.